Today, we are going to discuss about the limits at infinity. So to solve the limits at infinity, we have to follow these rules. So there are three rules. So number one, if the degrees of the polynomials are equal, then the limit is the ratio of the leading coefficient. So number two, if the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator, then the limit is zero. So number three, if the degree of the polynomial in the denominator is less than the degree of the polynomial in the numerator, then the limit is infinite. That is, it approaches positive or negative infinity. So before we're gonna have some exercises, now let's recall some properties of the limits. So we have here the limit of f of x as x approaches a is equal to infinity. And also we have the limit of f of x as x approaches a is equal to negative infinity. So some are the properties. We have the limit of f of x as x approaches 0 from the left is equal to positive infinity. And we also have the limit of f of x as x approaches 0 from the right. It is equal to negative infinity. And we have also this one is the limit of f of x as x approaches positive infinity is equal to negative infinity. The second one is the limit of f of x as x approaches negative infinity is equal to c. And we also have the limit of 1 over x as x approaches 0 from the right. It is equal to positive infinity, while the limit of 1 over x as x approaches 0 from the left, it is equal to negative infinity. And the last two, we have the limit of 1 over x as x approaches positive infinity is equal to 0. And the limit of 1 over x as x approaches negative infinity is also equal to 0. Now let us apply all these properties of limits as well as the guidelines on how to solve for the limits at infinity. Now, I have here three examples. Evaluate the limits of the limit of 5x cubed minus 2x squared plus x minus 1 all over 4x cubed minus x squared plus 12 as x approaches infinity. So to evaluate the limits for this kind of problem, we are going to identify first the highest power. Then whatever the highest power, you are going to divide each term by the highest power, or you multiply it by 1 over the highest exponent. So to do that one, so this is now the limit of 5x cubed minus 2x squared plus x minus 1 all over 4x cubed minus x squared plus 12. So since the highest power is x cubed, so I forgot here x approaches infinity. So since the highest power here is the power of x cubed, then I will multiply by 1 over x cubed to the entire numerator as well as the entire denominator. So I have now 1 over x cubed times 5x cubed minus 2x squared plus x minus 1 all over 4x cubed minus x squared plus 12. So still the same. I will multiply also by 1 over x cubed. Or if you don't like to multiply by 1 over x cubed, so you will just divide each term by x cubed. So it's the same story. So now let us simplify. So I forgot the word limits there. So I will write here the limits as then we have now 5x cubed divided by x cubed is equal to 5 minus 2x squared divided by x cubed. We have 2 over x plus x divided by x cubed is equal to 1 over x squared minus 1 divided by x cubed is 1 over x cubed all over. We have to do the same. So divide by each term by x cubed. So we can have now 4x cubed divided by x cubed is just equal to 4 minus x squared divided by x cubed is 1 over x plus 12 divided by x squared equals 12 over x cubed. And this is where x is approaches infinity. Now, apply the properties of the limits. So we have negative 2 over x. So if x is infinity, then 2 over infinity is equal to 0. So this will become now 0. So 1 over infinity is also 0, as well as this. And the other terms in the denominator, with having a denominator infinity, then that will give us the result of 0. So as you can see, so the remaining terms now is only 5 over 4. So we can write now the answer of 5 over 4. Okay, another solution for that is, aside from multiplying by 1 over x cubed, or another method for that is that we are going to factor out the highest exponent. So this is what I'm trying to say. So we have the limit of 5x cubed minus 2x squared plus x minus 1 all over 4x cubed minus x squared plus 12. Uh, as x approaches infinity. So the other solution for that is that I can write now the limit as x approaches infinity. So if I factor out the highest exponent, so we have x to the third power times, so 5x cubed divided by x cubed, so the quotient is 5, minus 2x squared divided by x cubed, so the answer is 2 over x, plus x divided by x cubed, we have 1 over x squared, minus 1 over x cubed is just equal to 1 over x cubed. So all over, we also have to write here the common factor of x cubed, then divide 4x cubed divided by x cubed is equal to 4, minus x squared divided by x cubed is 1 over x, and 12 divided by x cubed, we have plus 12 divided by x cubed is equal to 12 over x cubed. Now apply the properties of the infinity. So we are going to substitute x as a positive infinity. We know that 2 divided by 2 over infinity is equal to 0. So where is that here in our properties? So the limit of f of x as x approaches infinity, so we're applying this formula, this property. So the limit of 5, shall I say the limit of 2 over x, so where x is the positive infinity, so we are referring to this property. We have the limit of 1 over x as x approaches infinity is equal to 0. So that is what we applied for when we are trying to cancel out of 2 over x. So in the same thing, so since I already emphasized that the limit of 1 over x as x approaches infinity is 0, then we are going to apply that every term in this problem. So the limit now of 1 over the square of the infinity, so where x is infinity, so this is also equal to 0. So everything that has a denominator with a value of the denominator is positive infinity, so all of these will become 0. So the remaining terms now, we have the limit of 5x cubed, because x cubed times 5 is 5x cubed, all over 4x cubed as x approaches infinity. So the remaining terms now, after dividing and applying the properties of the limit, that is 1 over x as x approaches to positive infinity is equal to 0, then we have the remaining terms of the limit of 5x cubed over 4x cubed as x approaches positive infinity. So by simplifying that, we have 5x cubed divided by 4x cubed. The quotient is just equal to 5 over 4. So we can write now the answer as 5 over 4. Okay, for letter B, we have the given of the limit of negative 2x cubed minus 1 all over x to the fifth power plus x cubed plus 1 as x approaches infinity. So let me write the given here. Now, for that problem, we are going, since the highest power in the numerator is x cubed and the highest power in the denominator is x raised to the fifth power. So in the numerator, we have the highest power is to the power of 3. So I will write now here as the limit of x, the limit as x approaches to positive infinity. Since the highest power in the numerator is x cubed, then I will divide the given by x cubed. So we have negative 2x cubed divided by x cubed. So the quotient is negative 2, and negative 1 divided by x cubed. So the answer is negative 1 over x cubed. While the denominator, so the highest power is 5. So therefore, we are going to divide the denominator by the highest power, which is now x to the fifth power. Now, x to the fifth power divided by x to the fifth power is equal to 1 plus x cubed divided by x to the fifth power is equal to 1 over x squared, and 1 divided by x to the fifth power is equal to 1 over x to the fifth power. Then applying the properties of limits, so the limit of 1 over x as x approaches positive infinity, so applying this one again, all right, and then we can have, so this one will be equal to 0. 1 over x squared is also 0, as well as 1 over x to the fifth power is also 0. So the remaining terms now there we have negative 2x cubed. You multiply x cubed times negative 2, that's the remaining term, all over 1 times x to the fifth power is x to the fifth power. And now, simplifying that one by applying the law of exponents, so we can write now the limit of negative 2 over x squared as x approaches infinity. Okay, applying the properties of limits, like what I have said, that the limit of 1 over x as x approaches positive infinity is equal to 0. So that is what we are going to apply here as the limit of negative 2 over x squared is equal to 0. So the answer now for number 2 is equal to 0. And for letter C, the limit of x squared plus 2 of all over x plus 4 as x approaches negative infinity. So I will try to write it down here. So for letter C, we have infinity. Now we apply the same rule. So let's factor out first the highest exponent in the numerator. So we have here the limit as x approaches infinity. So the highest factor here, or the highest exponent, is x squared. And then we have to divide. So x squared divided by x is 1. And 2 divided by x squared is just equal to 2 over x squared all over. So in the denominator, we have the highest power is equal to 1. So we just divide now by x to the first power, or just x. Now dividing that one now, x divided by x is equal to 1 plus 4 divided by x is equal to 4 over x. Now apply the properties of the limits. So in this case, we know that 2 over x squared is equal to 0, as well as 4 over x is equal to 0. Now multiplying on what is in the remaining terms, so we have the limit of x squared over x times 1 is x as x approaches negative infinity. So there is a negative here. We have x approaches negative infinity, as well as here, there must be x approaches negative infinity. So which property are we going to use? So look at here again. So let us simplify that one first. So we have the limit of x as x approaches negative infinity. But in this case, class, we have the limit of x as x approaches negative infinity. So in that case, our answer is negative infinity, because this one, the limit of the given, which is x, our limit here is also x as approaches to negative infinity, then the answer is also negative infinity. Okay, so going back to our answers of letter A, B, and C. So in letter A, we have the degree of the polynomials in the numerator is the same as the degree of polynomials in the denominator. So going back to the rules, it says that if the degrees of the polynomials are equal, then the limit is the ratio of the leading coefficient. Now applying that rules, let us evaluate carefully. So we have here the given of since the numerator and the denominator have the same degree, then without showing the solution like this, we could say that the limit of this will be equal to the ratio of the leading coefficients. So when we see leading coefficients, it is the coefficient of the highest power. So in the numerator, we have the leading coefficient is 5, and on the denominator, the leading coefficient is 4, because 4 is the coefficient of the highest power, which is x cubed. So that is why our answer now here is equal to 5 over 4. So that is how to answer without the solution. Now for letter B, we have here the limit of negative 2x cubed minus 1 all over x to the fifth power plus x cubed plus 1 as x approaches positive infinity. So in this case, the degree of the numerator is less than to the degree of the denominator. So let's take a look on this property. It says that if the degree of the polynomial in the denominator is greater than the degree of the polynomial in the numerator, then the limit is 0. So is our answer 0 in letter B? We will see. Yes, because according to that rules, that if the degree of the denominator is greater than compared to the degree of the polynomial in the numerator is less than, then the limit of that will be equal to 0. Okay, now for letter C, in letter C, our example is the opposite of letter B, because the degree of polynomial in the numerator is greater than compared to the degree of the polynomial in the denominator is less than. So let's take a look again on the property number 3 or rule number 3. If the degree of the polynomial in the denominator is less than the degree of the polynomial in the numerator, then the limit is infinite. So it's either positive infinity or negative infinity. So in our case, for example number 3, we have the answer of negative infinity, because that is the given, the limit of the function as x approaches to negative infinity. Now let's try another example. We have the limit of 2x plus 4 all over the square root of 9x squared plus 2 as x approaches infinity. Now, although on the first three examples, I did not show that that is in the indeterminate form. So you can always check the given whether it is an indeterminate form by substituting the value of x. Now, if you're going to substitute the value of x here, we have 2 times infinity plus 4 all over the square root of 9 times the square of infinity plus 2, then it will give you now a result of infinity over infinity. So if that is infinity over infinity class, then that is one of the forms of the indeterminate. So since it is indeterminate, then we are going to apply the same rules as what we had in the first three example. Okay, for letter A, so I will write here, we have the limit of, since the highest power in the numerator is x, so I can factor out x. So as x here as approaches infinity, so I can write x times, so 2x divided by x is 2 plus 4 divided by x is equal to 4 over x. And on the denominator, so since the denominator is the square root of 9x squared plus 2, therefore, we're going to divide also by the square root of 9x squared. So we can write here the square root of 9x squared. So the square root of 9x squared divided by 9x squared is equal to 1 plus we have 2 divided by 9x squared. So we have now 2 over 9x squared. So they are almost similar to the process in the numerator without a radical sign. So what is only added there is you just write there the radical sign or the square root or the cube root, whatever the given. So that's why we are going to write first the radical sign or the square root of, and we have to divide each term by 9x squared, not only the x squared. Just not like on the without the radical form. So we just take only the highest exponent. But here it's different. That's why we have to write as well the 9x squared as part of our divisor. So therefore, 9x squared divided by 9x squared is equal to 1. And 2 divided by 9x squared is equal to 2 over 9x squared. Now, we are going to simplify further. So we have here the limit of x as the limit of x times 2 plus 4 over x all over. We're going now to take the square root of 9x squared. So we have the square root of that is 3x times the square root of 1 plus 2 over 9x squared. Or you can write also here the absolute value of x or just x. Now from there, we are now going to apply the properties of the limits. So we forgot to write there. So we just write here x uh, approaches positive infinity. So we have 4 over x will be equal to 0 according to the property of the limits, that the limit of 1 over x as x approaches positive infinity is 0. So including also the denominator of 2 over 9x squared, this is equivalent to 0. So the remaining terms there we have the limit of 2x because x times 2 is 2x all over we have 3x times the square root of 1. 3x times square root of 1. We have square root of 1 is also 1. So 1 times 3x is 3x as x approaches infinity. So simplifying this one, 2x over 3x. So the x will be cancelled. So the answer now will be equal to 2/3.